interesting question today for you pertaining to thermal physics. And the question states that it's to calculate the final temperature after all of the event has taken place. At what temperature would the copper block end up if it were provided 4 amps worth of 30 voltage power for 300 seconds, which is about 5 minutes. And if we supplied that much power to energy to a copper block cylinder of 2 kilograms, and knowing that its specific heat capacity is 435 joules per kg per Kelvin, and the starting lab room temperature was 18 degrees or 291 Kelvin, what temperature would it end up at after 300 seconds? So the calculation is pretty simple, and I'll lay it out for you. Paperweight. So we all know the famous E equals mc delta T. But in this case, we also have to consider E equals P over T, which is E equals PT, which is IV times T, which is IVT. So we've got all of these three and this, but we don't have one of this, which really means TF minus T initial. So we will now have to equate electrical energy supplied into the circuit to find out the initial temperature through the formula of thermal energy. So that'll be IVT equals MC T2 minus T1. And if you multiply IVT together, it'll be 30 times 4 times 300. That'll be 36 joules, and then followed by the mass of copper, which is 2 kg times and times times T2 minus 291 Kelvin. So this is what it would look like: 36,000 joules, which is a product of 30 times 4 times 300, and equivalent to 2 times 435, 2 kgs times 435 joules per kg per Kelvin times whole bracket open T2 minus 291. And then we'll have to find out what the other final temperature was. So bear with me, stay with me. So the final temperature would be 36,000 joules divided by 2 times 2 kgs times equals T2 minus 291 Kelvin, and that would be 41.4 kelvins. So there's a difference of, and then if I move 291 to the other side, it'll be 332.4 kelvins. So the final temperature would be 33242, or 59 degrees Celsius. So it took joules to induce temperature differential of let's just 60 minus 18, 42 degrees in 5 minutes. And obviously we are ignoring internal resistance. We're ignoring V squared over R I squared hang on, P equals IV. We're ignoring we're ignoring that. We're ignoring internal heating. And all the other circuit deficiencies. So as you can see, you can see that we started off with 36 kilojoules worth of energy from the circuit input over 5 minutes, and that energy was able to take the temperature from 18 degrees to around about 59.4, around about 60 degrees. I shouldn't say 60, but just for simplification. And then there was a change of 42 degrees in 5 minutes, and if you wanted to quantify it, that would be 8.4 degrees per minute. 8.4 degrees per minute. So it was adding 8.4 degrees to the temperature of the copper per minute. So 8.4, 16.8, and so on and so forth till it reached 59.4 degrees. So I hope we were able to take a look at this thermal physics question in relation to electrical energy, electrical heating, and we were able to appreciate the circuitry performance aesthetics. And I hope you learned something today. If you have any questions, please post them down below and I'll try my best to answer them. Have a lovely day and take care. Bye now.